our first session for tonight, which is build serverless app with Cosmos DB and Azure Function with Mohammad Asif. Mohammad is a Microsoft MVP for Azure. He's based in Singapore. He's one of our organizers here in SG Data Platform User Group. Uh, Good evening, Asif.
Hi, Pio. Thank you for introduction and thanks for organizing this meetup. Thank you everyone for joining today, and I'll be speaking on building serverless app with Cosmos DB and Azure Functions. And if you have any questions in the middle, so you can ping in the chat box, or I will be not monitoring, but yeah, Pio will help me to tell me if anything is there.
Yeah. Do you want me to interrupt you as the questions come in, or?
Yeah, you can, or maybe I think if you can ping me in the middle also is good. That's how I
All
can
right,
help.
sure. I'll let you know when there's that question.
Sure.
So with that, I'm gonna hand it over to you. The floor is yours.
Thank you. Are you able to see my screen?
Yes, we can.
Okay, great. Thank you everyone for joining today. So we are going to discuss about how we can build an app with Cosmos DB and Azure Functions, serverless app. And about me, I am Asif. As P already mentioned, I'm Microsoft MVP and uh, it's like organizer for data group and Azure community as well. And today we are going to talk about the modern apps. So what is the modern apps in reality? When we talk about the modern apps, what the actual thing comes in a mind first? The volume, the variety, and the data. The concept of 3V of big data. So if we are dealing with a lot of volume of data, or if we are dealing with the variety of the data, and the data frequency is quite happen. So in that kind of scenario, we need to think about how we can scale our application, how our application can be fault tolerance, and how it can be replicated in multiple regions. So these all things comes in picture, because there are a lot of issues which we face with the, suppose if you're using current apps, like if you're using any three-tier architecture apps. So what are the issues you are going to face with that? So let's take example. If we have simple ordering applications, so like you have a application if you want to order a goods, and that goods need to be shipped out, and you want to print the invoice, and you want to keep the record of the inventory. So it is a very simple use case which is common in most of the scenario. So what are the challenges we can face in this use case if you're using a traditional app? First is the tight coupling, because it's all the applications. Suppose if you are shipping the goods, it's a different system, and ordering the goods is a different system, or printing invoice, inventory maintenance is all are these different systems. So it might be that these systems are dependent on each other, or there is a tight coupling between the data transmission, and we want to integrate. So integration is also a bigger challenge from if we have a multiple systems. And suppose you are or means like orders at certain period of time, like maybe in evening, or maybe on some holiday, or some offers is going on your website, and you are receiving a lot of orders at certain time. So your performance for reading or writing or code application is means like you need high performance read and writes, because to get the data or to write the data. And it might be a scenario that a lot of orders are failed, or maybe the website is hanging, or it's not performing well. And there are conflicts, like means like updating the database, and that usually happens in normal SQL Server, or the traditional databases we have. And to avoid that, what we do actually is, in current words, what we do is we scale vertically. We add more servers, we add more RAMs, and because to improve our performance. So how we can avoid this kind of issues uh, with modern apps? How we can convert this app into modern apps? So let's suppose if we split the process of ordering goods and shipping goods, and we keep some the queue in the middle. Like suppose whatever the orders you will receive, it will be processed via queue, like event-driven apps. And so it will be means like suppose you are getting a 10,000 requests or 1,000 requests in a certain period of time. So all the requests will be in a queue, and so you are doing the decoupling of the services or the applications. And you know that in a queue, like if you're using a RabbitMQ or if you're using IBM MQ or whatever the queue you are using for that, so you are auditing how your data is being processed. And you know that if there is service being failed in any one of the process, so you can debug and you can find out the issue easier or in easy way. And these, if you are going to decouple the application in different services, so it will be more easy to integrate with one another service, and you can find out the issue with very easily. So that's what we are going to do. Actually, by end of the session, you will have an idea like how we can build means like event-driven apps or scalable apps using Azure functions or Cosmos DB. How, where exactly it comes into picture, I will explain you. Suppose if we are going to break into different services, so for ordering the goods, we can have one service. Between shipping goods and printing invoice, we can have one service, and shipping goods to inventory, we can have another service. So we have split this into means like we have decoupled the application. We are, and these all service will be audited, and we can find out the integration. So this will be like kind of a microservice architecture, we can say that. Okay. So where exactly it will be helpful? It will be helpful in terms of fault tolerance. Suppose if there is any issue also, so we know that how we are going to log the errors. It will be it will provide stability. It will provide a more auditing, and we can update easily all these services means like separately. And we know that we are going to do with the versioning, so we know that which services which version is going to run on that. So if we have the traditional applications, so these kind of issues we face a lot in terms of managing the application, in terms of auditing, in terms of updating, and yeah, obviously the scalability and availability is another issue. So how we can build this kind of microservices? So this kind of microservices we can build by using Azure functions basically. And that's where, because all these operations we are going to do on the on the data, so we need a database which is scalable with the high availability. And there should not be means like it might be a scenario that we are getting a data which is not the structured data, which is in form of unstructured data also. Because suppose you want to capture some of the information like about your inventory information. As example, suppose you are keeping all your goods in some inventory, and in that inventory you have tagged all the assets or all the goods with RFID tag or maybe some other tag. And you want to, so you want to capture the information. Like suppose if someone is unauthorized person is going to take the some goods out of the inventory without your notification, so we want to capture the data. So that data is captured in terms of some IoT device is already on the gate of the inventory, which is capturing if there is a asset is passed from the the gate or something. So that event we are going to capture, and that tag we are going to capture. So that type of data is unstructured data, because it might be a scenario that with asset tag, or maybe you are getting some other information, maybe in IP information or some other data. So you want to leverage the data to get the actual information and process into database. So in that kind, to manage that kind of scenario, we need a database which is able to capture unstructured data also. So in to avoid that kind of failures, so what we do is Microsoft provide the Azure Cosmos Db. It is a globally distributed database which is massively scalable, and it is a multi-model database service, you can say. So what features it provides? It provides you tunnel global distribution, means you can suppose you are running an app in Southeast Asia region, and but you have a branch which is another region like East Asia or maybe in Europe or somewhere. So you want to replicate, because and in that region you are getting a performance issues in terms of your app is data read, or maybe the listing is a problem. So within just few clicks you can replicate the data from one region to another region, and that I will show in going forward. We'll show in the demo. We'll see in demo how we can replicate the data from one region to another region, and it is very easy to scale out. So because if the data will be available in a different region, it will be very easy to process the data and get the data. And with Azure Cosmos DB, you don't need to worry about how your data is going to query the data, query performance, because Cosmos DB do the auto indexing, and it also helps to scale the number of containers which is storing your data automatically, and it provides 9 means like 99 percentile of low latency, and they're having a different consistency model. Suppose you want your app to be consistent in all region, because when we are talking about the replication in another region of the data, it may take some time to replicate the data, but in some region you want a consistency level very strong. And because suppose you are using app which is for your shopping cart website, right? So in that there are products. So and if someone have made the payment in one region to another region, okay, and the product is already sold, so the data needs to be consistent because it's a payment you are going to process with that. So in that kind of scenario, we need a consistency level. So there are 5 consistency level Azure Cosmos DB provide. So you can set up based on your need, and the SLA is 99.59 they provide. And the best thing I like about Azure Cosmos DB is you can capture, or you can query the data, means any type of data like key store, key value, column family, or document database, or graph database. And they having different APIs for suppose your data currently you are using an app like MongoDB or Gremlin, or you have a data in Cassandra. But even though you can query from Cosmos DB those data, so you can leverage. Suppose you have app which is like React and Cassandra, or React and Mongo, so you can use Cosmos DB APIs to query that data also. And that's one of the best feature of Cosmos DB. So like it's a kind of layer, so you can query any table APIs. So and by default you have a SQL API. So if you have a data in a SQL server, you don't need to worry about it. You can run all the SQL queries in Cosmos DB as well. In terms of feature, it is a more multi-model database, and it provides 99% of queries like less than 10 milliseconds read operations and 15 milliseconds for the write operations. Designed for the high throughput of the data, and ensures the availability and consistency with 5 nines, as I explained already. This is also provides a replication is from one region to another region. How we are going to replicate the data means, like suppose if you have a data in East Asia and we want to replicate in US or some other region, we can do that replication as well. And by default, you don't need to worry about the indexing of your data. You can do that indexing. Cosmos DB already do the indexing automatically, but if you want, you can also define your indexing keys or partition keys, how you want to save your data. Okay. And there are 5 different levels of consistency, like strong, bound, and stainless, and session. I will show in while the demo I'll do. And you can also, this is a recent feature which they have added. You can run the analytics on the data which is available in Cosmos DB. That's called no ETL analytics, and with the help of Azure Synapse analysis. So you can analyze, you can do the data analysis with the help of Azure Synapse analytics API, and you can generate the Power BI report or whatever the means, like whatever the other useful feature you want in that. So how you can start, because Microsoft Azure is providing a 30 days free trial. You can just go in microsoft.com and you can register with that. And with Cosmos DB also, they are providing a 30 days trial. So you can register. You don't need the credit card details or subscription details for trying the Cosmos DB. And you can also run the emulator in your local. If you are running the emulator in Windows, so you can just go and install the exe. But if you are running a Mac or Linux system, so in that kind of scenario, you need to either use a Docker, or they have a means like a option for Mac OS also. You can download, but you need to install the certificate. So I have because yesterday I'm using Mac, so I written a small blog for using the Docker. So if you are interested, I will provide the link so you can see how you can run the Cosmos DB emulator locally in Mac or Linux VM. Before going to the demo, I will explain like how we means like what are the, when we are going for creating a Cosmos DB account. So what we need is for Cosmos DB you need to have an account, and in account you can have multiple databases. And in one data means like it can have multiple containers in one database, and in containers there will be items. So basically items will be like I think the same as it is your tables or yeah. In one database we can have multiple containers, and containers will have like a collection, graph, or table. So which type of data you have, suppose you have a data in SQL Server, so you can use means like SQL table APIs, so you can query by using SQL Server. Okay, and if you have like a collection database, so you can using a document DB, or yeah. And in items, basically in Cosmos DB, we have a store procedure, triggers, or UDF functions. What is the actual difference between the relational database and this NoSQL database Cosmos DB? So there is a basic difference. Like in relational databases, all the data is stored in terms of rows, which is the table rows. We know that. And when we are talking about the NoSQL or document store database, so in this all the records are stored as a document, and they having the columns, but they having the properties, and which is strongly typed. So you know that your user ID is linked with your other table like as a foreign key, and it is very tightly coupled. So if there is any change in this, it means like it's need to be updated here. Okay, but it is like a schema free. Suppose in one record you haven't entered date of birth, or maybe some symbol, means like this is missing, but in other document you can have that property. So basically it is pulled using the key value feature, like queries related to key value feature, and it is highly normalized and denormalized. As I earlier explained, this is a consistency level. There are 5 strong bounded sessions, and so I'll skip this. Yeah. In terms of storing the data, we have 2 types of partitions basically in Cosmos DB. One is a logical partition, and second one is physical partition. So logical partition is like you can create a multiple logical partitions where exactly you are storing the data with some kind of partition key, but that is not the actual partition. So that is not where the actually your databases data is going to store. There will be a physical partition. So maybe it might be a scenario that 2 or 3 logical partitions are available in one physical partition. Okay, so basically, but that mapping is between the logical partition and physical partition is done by the Cosmos DB itself. So you don't need to worry about where exactly my data is going to store or all those things, because that indexing or partitioning is mapped by the Cosmos DB. And in today's session, we will see that means like suppose if we this example, suppose you want to build a means app for your shopping cart website, and you have multiple customers. Okay, you want to store the customer information, and you want to get the customer informations, or if there is any change in the customer information. So how we can update the information quickly. In Cosmos DB, whatever the data you get, so these data is recorded in terms of change feed. So change feed is nothing but like kind of logs. So what exactly this feature is really helpful in terms of scenarios to capturing the events. Suppose you have a website which is in different regions, like maybe it is in Singapore, it is in Malaysia, it is in some other region, and you are buying some product from there, and after that the other person is also buying on the same time. So means both have done the payment on the same time. So which will be executed first? So it will be based on the change feed. So whoever is on Cosmos DB, because it maintains the consistency level and availability on both region. So it will check based on the change feed which property is executed first, and it might be based on the Azure functions it will check, or it might be based on the database triggers. So I will tell exactly what is the use of Azure functions and Azure Cosmos DB database triggers in that. So change feed basically helps to trigger to the API when the document is inserted or modified. And basically it's a kind of log. So it helps to process the real-time streaming of the data. And yeah, for IoT analytics. So this is a very useful feature in terms of event-driven architecture. In basically how the scalable apps works is change feed in that there are three types of features. One is input binding, second is output binding, and third is Cosmos DB triggers. So what exactly the input binding or Cosmos DB trigger is? Suppose you are getting the data from the change feed. So there might be Azure Cosmos DB trigger. So it is similar to SQL trigger. In SQL Server database, you have a triggers, right? So it based on the event. Suppose you got any event to event for saving the records, or maybe inserting the records. So it will be triggered on the time. So it is Cosmos DB trigger the same. It will execute the Azure functions, and you want to do some operations. You want to do the trigger email, or you want to execute some payment API, or whatever you want to do, you can do that. Input binding is basically you want to get the details from from database. So in that kind of scenario, so it's like a get properties. When so in usually when we do any application, so we have like CRUD operation, right? So in CRUD operation we have for creating the data, for means retrieving the data, we updating the data and deleting the data. So there will be triggers which will be executed to trigger the Azure functions, and with the help of Azure input binding, we can get the data from the Azure function. So Azure input binding, what exactly do? It retrieves the data from the Azure functions, and output binding, what exactly it do? It's output binding. Basically, it execute the Azure functions for saving the data into Cosmos DB, or wherever we want. So I think it'll be more clear when I will show exactly how we are doing in demo. So let's say it's if you want to buy, in the shopping cart website, so where exactly we can use the input binding and output binding or database triggers. So there is you need to understand input binding. The basic difference is input binding and output binding and database triggers are completely different thing. Input and output bindings are not database triggers. It's input and output bindings are just connectors, and database triggers is a kind of event. So when any event is happening, we need to use a DB trigger, or for connection between like whatever the operations we are performing. to Azure Cosmos DB. So we have to use input binding or output binding. So like suppose you want to do the checkout in a shopping cart website. So with the help of input binding, first of all, we are going to get the customer informations like or maybe say product information, if this product is really available or not. Okay, so in that scenario, we will use the input binding. But when we get the details of the product, it is available and we want to order the product. So in that type of scenario, we will use after that we will use the DB trigger because we want to purchase the product. So purchasing, we are doing event, we are performing some event on that. So then we will use the DB trigger, and we want to save the data into means like add the data into cart, or we want to purchase completely the product. In that type of scenario, in saving the data, we will use the output binding. Hope it's clear. If anyone have any doubt, you can ask, or you can put in the chat box, and maybe I'll go for the demo then. Do you have any questions?
There's no question yet on the chat, but if there's anything, I'll let you know.
Sure, thanks. So for creating the Cosmos DB DB trigger, you don't need to write the big logic. So it's you can see the very simple code here. In the functions, like you need to create an Azure function, and in Azure function you need to define a Azure Cosmos DB trigger, and what is the database name you are, where exactly you are going to execute this trigger, because this is the Cosmos DB database name collection, which collection you are going to do this operation, and what is the connection name. And then you can perform the operations like you want to get the details or whatever you want to do. Okay, so now let's me so in today's demo, what we are going to do is we are going to create two APIs which is built on for getting the customer information and creating the customer. So suppose we have app, we need to create an app. So for creating an app, we don't want to write the whole application or logic. I just want to create APIs to communicate quickly, because it might be a need that you need to create the API within few minutes or something. So let's see how we'll exactly do that. Okay, and we want to save the data into Cosmos DB. So let me create first a Cosmos DB. Sorry. So you need to go into databases, and there is Azure Cosmos DB. So you can create, there are multiple APIs. You can do that. Either you can do the core SQL, or you can create resources for, if you want to query the data from the MongoDB, then you can do with use the Azure Cosmos DB API. So these are the predefined templates available. Or you want to capture the data, you want to get the data from Cassandra if you are using any app, so you can use. So I will use the core SQL. Let me create if anyone have any doubt, you can ask, no issue. Yeah, I know it's quite new concept. So account name, we can give demo account Cosmos. Okay, so if you are choosing the it's like location like south, because there are some regions they having the backup policy. So if you are using some region, like suppose if you're using US, I don't need, you need to, they will do automatically backup. But if you're using some other region, so I think you need to do backup. We need to select the backup also. It might be a local redundant backup, or maybe you want to replicate the data in different region. So you have to select the geo redundant. Okay, but to save the cost, I will choose the locally redundant. Okay, and this is apply free tier discount. So you can Azure Cosmos DB provides a free tier account for 30 days, as I earlier mentioned. So you can create a free tier account, and yeah, then you can upgrade also if needed. Next is global distribution. So it's if you want, there are multiple features. So you want to data for geo redundant, and like multiple region writes. Suppose you want to perform data which is writable from, you want to update data in different regions. Like suppose you have application which is in Singapore, also you want to do the write operation, and in Malaysia also you want to do the write operation. So you can enable this feature, or means like whatever the availability zones you want, so you can enable this feature. As of now, I will not enable that. Yeah, let's go and see. So this is a backup redundant storage redundancy. So you can either do the zone redundant backup or locally. Suppose you want to backup in some particular region, so you can choose a zone redundant. Otherwise, you can choose a locally redundant. So I will choose a locally. So it will take just a few minutes to create. So until then, let's go and try to create Azure functions. So what we need exactly to do is we are going to create two Azure functions, which is going to interact with Cosmos DB for input and output binding. So with the help of input binding, we want to retrieve the customer information, and with the help of output binding, I want to save the data. So that's work. And Cosmos DB, we can use Cosmos DB triggers. We can use for capturing the events. But I think let me go and quickly create Azure functions first. Use demo resource. Function name is demo app. Okay, runtime, because Azure functions you can write in any one of the language. Suppose if you are familiar with .NET or Node.js or Java, so you can choose based on your comfortable level. I will choose the .NET because I started with .NET. So yeah, let me Southeast Asia. And next is hosting. I want to let me just, if you want storage account, so you can create a new storage account, or you can yeah, it's a new. So and you want to perform this operation, because I will choose the by default Windows, and there are different plans like consumption plans, functions premium, and app service plans. So I will use the serverless consumption plans. So it will be helpful for why, because it will be based on my logical read and write operations. So how many requests I'm making on that database, so it will be charged based on that. Yeah, so I want to enable the application insights for getting all my requests, how many requests I'm making, and yeah, to get the analytics of the data, sorry, logs of the data. So yeah, let's go and create quickly. It will just take a few seconds. I think, yeah, you can see my Azure Cosmos DB is ready. Let me go and see here. So you can create containers by default, item containers. Okay, and you can see here the Data Explorer. So Data Explorer is basically your for new container is my create a new container database ID. So I want to create a web store, and this is database is auto scalable. So you want to do the auto scaling, means like suppose your database capacity is full, so you want to scale the database like automatically, or you can choose the manual if you want. And this because whatever the read and write operations you are doing on database, so that's actually calculated in terms of RU, which is and based on the RU it scales automatically. So and the costing will be done on based on the RU per unit. So you can let me container ID. So I want container like customer. customer information I want to store. So I will create one container as a customer ID, and I will give the partition key is ID. And I can create in one database, I can create a multiple containers. So let me show you how exactly we can do that. And until then, means like you can see here, we have that is a global distribution. 1 minute, let me show. So replicate data globally. So this replicate data globally is let's create first this and then we go there. So replicate data globally is a feature. Means all this currently I am means my data is available in this region, Southeast Asia. But suppose if I want to replicate my data in East Asia region, or if I want to replicate the data in Germany or Central or Northeast region, so we can just double click on that and my data will be completely replicate in that region. So this is a very useful feature when you have a multi-region app and you want to means like you want to improve the performance in that region. So you can replicate the data, just you need to just click double. So you can see by Norway East is added here, and you can just save it. So this whole data will be replicated there. And let me discard for this. And this is the consistency level which I was talking about. So by default, we have a session consistency, but you can make it strong. Suppose if you want, because some payment related transaction, and you want that data, means like API to be very consistent. So you can enable the consistency level strong, and yeah. So you can have eventual consistency, like you want some data to be replicated within like the time duration is not very stringent, so you can say that we can have a data in within a few milliseconds. So I think you can use the eventual frequency. Okay, I think let me go and see there if my data is ready. Yeah, so you can see this is the database which I have, and this is my containers. So customer I have, and these are the items. Items are nothing but your in document database, items are something similar to your table rows. So it's like all your data will be stored in terms of items, and you can have a SQL procedures, and this is the database trigger which I was talking about. So we will create the DB trigger when there is any event happening. So all whenever the data is saving in Cosmos DB, so all the data logs will be captured in terms of transaction logs, like change feed logs. Okay, and with the help of the change feed, we can trigger any events. For suppose you want to send the email notification, or you want to save the data, or you want to save this whole amount of container data in some other containers. So those features we can do with the help of triggers. So let's go and quickly and create the Azure functions and integrate with the. So we have, I think, already demo resource. We have already created the Azure functions. Now let me go and quickly create Azure functions. If you have we want to create two APIs here. First is for getting the customer details. Second is for adding the customer details. So let's go and quickly first do the add customer details, because first we want to add the data into customer, and then we want to retrieve those data with the. So let me go and quickly create. If you don't have if you don't want to create in a Visual Studio Code or something, so it's better to I prefer by doing in dev portal, because today morning when I was building my app in VS Code, and somehow I got error which is in my Mac OS. I think there was some sharing error. So yeah, then I did in Azure portal. So let me go and create the HTTP trigger. So there are multiple templates available, but for HTTP trigger, suppose you want to receive the HTTP request, And this HTTP request you can call using from some other application. Suppose you are using a .NET or Java app, or maybe some Dynamics or SharePoint app. You can call this API directly from there, and you can create the customer in the application. So that's very helpful in terms of integration. So you can just expose the API, and that API can be consumed by any applications, and we can do the operations. And there are queue storage. So suppose you have a massive amount of request coming, means like for buying a product or something. So in that kind of scenario, the queue storage trigger will be very helpful. Okay, and you can have a scheduled timer trigger. Yeah, so there are several templates you can explore. I will just go for the Azure HTTP triggers. Sorry, oh, I didn't choose the name. 1 minute. Let me go and create one more request. Sorry, I didn't choose the name. HTTP create customer. I think I have only 15 minutes remaining, so I'll just try to do quickly. Get customers. Okay, for this, I think I'll just do because I have already written the code for this, and then I'll explain how exactly. So you can see here, when we have created this API, I have code and test. So you can just come here and you can write your code by default. Okay, and this is the integration where exactly you want to integrate with any other. So if you see here, this is my trigger, this is my functions. Okay, and this is the HTTP request I am expose, means like you are getting the data. So suppose if I want to create the customer, so creating customer, we are interacting with the Azure Cosmos DB, right? Because we want to save the data into Cosmos DB. So in that scenario, which binding we will use the output binding. Okay, so for output binding, we need to have means connectivity at the output level. But suppose if we want to get the information from the database, so in that type of scenario, we will receive the input binding because we want to get the details from the data. So then we will use input binding. So for creating the customers, we will use the output binding. Okay, so I will use Cosmos DB because I want to save the data into Cosmos DB. Okay, and let me go and sorry, my data source. What is my Cosmos DB database name? So my database name was web store. And my collection name was customers. And this is currently I don't have any connections. So what I will do is Cosmos DB. Okay, so I will create the connection, and then I will create the output binding for this. So this is quite simple, the integration you have done with. So you can do the configuration with any other Azure services. If you have you can store the data into, you can create the output bindings for a different app also. You can do same with the SQL Server or maybe blob storage, wherever you want. So this is my integration, and then once it is done, so we will write the code for. So what exactly in the background it will happen is when we trigger this function, so it will do the operations like create operations, and it will save the data into Azure Cosmos DB. in terms of whatever the format we want. But suppose if we are doing a trigger for getting the customers, so in that scenario, there will be no output binding. So there will be only input binding because we want to get the data from the customer database. So we will do the configuration here. Okay, now I think it's done. So let's go and quickly first try to run this, and if everything is okay, then we will do that. I have a customer code. Let me just go and so first let's do the test run and see that. So this is the method. You can do the post request, and you can do the function key. Okay, so let's run this and see that if everything is up and working correctly. Yeah, you can see this is a hello Azure. So by default, when you run the function, you will get this message. Okay, now let me quickly go and replace. Okay. So if you can see, this is the Azure functions. What exactly I have done is I have created one class because this is the .NET application. So if you're familiar with .NET, so you know that we have to create a class for storing any entity or data. So this is my customer class, and what exactly I'm doing is this is the normal action results. We are getting the HTTP request, and this is the output we are going to store. So, and this output document is also in HTTP bindings. If you see, this is my document parameter. So this is my output document, which is I have exposed here in my code. And I'm going to read the body, means like whatever the parameters I'm going to pass as a parameter. So yeah, and then this is my object I'm going to store. So let's see how exactly it will work. And this is dynamic data JSON convert.deserialize object. So what exactly it will do, it will read the data from the body, and it will deserialize the convert into JSON, and then it will save into the database. So with me, I think this is my the data format which I'm going to store and create, because this data you will pass from some other application. Maybe suppose you are using a SharePoint Dynamics or .NET or whatever. So we will pass the data in this format. Okay, and run the application. So this request will be post request, and so you can see we have got the response HTTP 02. Now let's go and see the Cosmos DB if we got any data or not. Data Explorer. So you can see this is the data which we have received. Suppose if I want to add more data, let me go and create a S02, and we can have. So this actually function is already created. Now this function can be called by Postman or wherever exactly you want to use. So you can use this get function URL, and you can call this API from this API is ready for use. So now let me go and quickly create for get customers. So get customer, what exactly integration we need to do? We need to do the input binding, and input binding, how exactly we'll do? We will do the Cosmos DB input document, and database name is webstore, and my collection name was customers. My same connection I'm going to use, and let's do this. So this is my input binding. So we are going to get the details from the customer. So in terms of and HTTP means like JSON format. So let's go and quickly create for the API for getting the customers. So So in this, if you see, I don't need to write much code. This is my class, customer class, in which format I'm going to get the data. And it's like, this is my input binding parameter, which I have given when I created from the integration with Cosmos DB. And this data I'm going to get in terms of list and going to display that. That's it. You see, you don't need to write, big code, and it's like quite very simple. Let me go save. Let me save and show you how exactly it will work. So my both APIs will be ready because this is going to be a GET request. So let me go and run this. So you can see I have created Asif 1 and Asif 2, two customers, and I got the information in terms of JSON form. So this is, you can use same as this. You can create Miss Azure functions for delete. So all your CRUD operation is ready within half an hour. So you can use this in anywhere in your app for building the APIs and saving the data in terms of Cosmos DB, and this data can be replicated in any one of the region because Cosmos DB is highly scalable, and they're having multiple reads in different region, multiple writes. So you can globally distribute this data into, so within 1 hour you can just create the APIs using Azure functions, integrate with Cosmos DB, and can replicate in another region to make it available. Yeah, so this was I think my demo. So if you have any doubt, I can ask.
There's actually one question on the chat. Can I pass from Francis? Can I pass store my data instead to an Azure SQL DB or a Postgres SQL
Yes, you can.
instead? What would be the deciding factor to use Cosmos DB over the other databases?
Yeah, actually, that's a very good question because if you are using Azure SQL database and Azure PostgreSQL, so the best thing about Cosmos DB is suppose if you have an app in different applications, like maybe in you have an app in MongoDB or Cassandra or wherever. Okay, so you can query the data by using Cosmos DB. Okay, and second thing is that the basic functionality which is Azure Cosmos DB provides is globally distributed, means like data can be replicated within a few seconds by using a global distribution feature and replication. So you can replicate your data and make it available in other region within few minutes and few seconds. While and suppose if you have a data in terms of like the NoSQL format, means like unstructured data. So unstructured data is obviously the Cosmos DB will be the first choice because you cannot save those kind of data. And if you have a requirement to store data in non-structured format, so then you have to go for the Cosmos DB. Structured data, obviously you have to go for this, and there are really good features in terms of availability, in terms of replication, multiple read and writes. Those are still not available in Azure SQL DB. Some of the features are available in Azure SQL DB, but not all. So in that scenario, I think Cosmos DB will be the first choice. Is my answer is okay, or you have any other questions on top of it? Yeah, thank you. Any other questions? I will commit my code. This my available in my code, my GitHub repo. So I will provide the link soon. Yeah. So if you have any questions, you can ask, or maybe after the session you can also ping in a chat box, or you can reach me out.
All right. If you guys, if any of you have any other questions, just feel free to drop it on the chat. Asif will be with us for till the end of the episode, so he can answer your questions on the chat.
Yeah, and one more. I want to add one more point is the best feature about the Cosmos DB is the change feed. So I think that's also one surplus point compared to Azure SQL DB and PostgreSQL, because you can get the change feed information, and based on that you can perform any other operations, like in terms of saving the data, processing the data, which is highly scalable and service. So that's one of the feature to use.
All right. So thank you very much, Asif.